Generally, this D dimension will be large, and then the largest dimension is A, and then the B is the least dimension. So, for a rectangular cavity resonator, we can say D is greater than A greater than B. We can say like this. So, if D is very large, that means as it is in the denominator, as D is large, this value will be small. This value will be small, and then A is also large. So, this value also can be a small value, where B is a small dimension. Generally, this value is the largest value, then second largest, and then this is the least value. This is the least value. So, we want the least resonant frequency, that means this F0 value should be minimum. So, to get this minimum value, of course it is minimum value, we no need to change anything here, that means this term can exist. So, that means the P can be equal to 1, okay. And then another one is this is the second largest or second least value. So, we can say that this A also can exist, that means M also can exist. And coming to the N, if this N is equal to 0, then this largest value can be made to be 0, okay, so that we can get the minimum value of F0. So, we can find what is the dominant mode that is propagating through the rectangular cavity. That means it should be either TE101 or TM101 is the dominant mode that is propagating through the rectangular cavity resonator, okay. See, for a rectangular waveguide, A is greater than B, and this is whether it is A or B, that is less than D, and hence F0 will be having a minimum finite value for M is 1, N is 0 and P is 1, and hence the dominant mode is either TE101 or TM101 for the rectangular waveguide, okay. So, this is the dominant mode for the rectangular waveguide, and so like the same we have to derive the dominant mode for the circular waveguide also. So, for the circular waveguide, we take the resonant frequency of the circular cavity. So, for the circular cavity, the resonant frequency is defined as F0 is equal to C by 2 pi root h square plus p pi by d whole square. And for if you take for TE, the mode is defined as NMP, and for TE mode in this H is also, let us write it as HNMP is equal to P dash NM by A. And for suppose if it is a TM NMP, then H is equal to PNM by A. So, it is different for TE mode and TM mode. This F0 resonant frequency is different for TE mode and TM mode. So, F0 is how for which we are going to get the minimum value. We have to just consider. For example, if you say whether it is P dash NM or PNM, the denominator is A. So, if denominator, if A is large, this h square can be minimum. Anyhow, A is the radius of the, if you take this is a circular cavity resonator, this is A is the radius of the circular waveguide, and this D is the depth of the circular waveguide cylinder, okay. So, obviously D is greater than A, okay, but here let us consider, as A is the radius, let us consider the diameter of this, that means whether D greater than 2a or D less than 2a. So, if D is very large, then we can say that if D is a large value, it is going to give that this term is the minimum value. If D is more, if A is more, then this term is going to give the minimum value. That means this is minimum value for D greater than 2a, and this term is going to give the minimum value for D less than 2a. So, we have to check whether either D is greater than 2a or D less than 2a, and depending on that this P can be made to be 0 or 1. Suppose if it is giving the minimum value, then P can be 1 at this case, okay. But if it is giving the maximum minimum value, that means obviously this is giving the maximum value, then in this case P should be equal to 0. That is the representation for the mode. So, now let us see. So, for a circular waveguide, we have to check whether D greater than 2a or D less than 2a. See, so what we have taken is, so when this D is large, okay, so that means this is the case when D is greater than 2a, okay, it is giving the minimum value, and while it is giving the minimum value, you can take P is equal to 1. So, in that case NMP, in this NMP, this P can be equal to 1, okay. And suppose if you take this case, if 2a greater than D, then this H is giving the minimum value, and when this is giving the minimum value, if it is giving the minimum value, we have to take this P is equal to 0, because this value is greater than this, and so it is increasing F naught. So, we have to take P is equal to 0. That means the mode should be TM110, because here also it is NMP, okay, NMP, okay. Anyhow, so these are the dominant modes in the circular cavity. So, for TE it is 111 is the dominant mode, and for TM it is 110 is the dominant mode in the circular cavity, okay. Whereas for rectangular cavity, TE or TM 101 is the dominant mode, okay. So, let us see the summary of this session. So, we have derived the field expressions for TE and TM in both rectangular cavity and circular cavity, and also we have obtained the resonant frequency, and from that we have derived what is the dominant mode in the rectangular cavity resonator and the circular cavity resonator, okay.